This question is asking us to identify parallelograms, rectangles, and squares. So we have three figures up here, and it's just asking us a question about each. Which figures are rectangles? So in order to be able to identify what a rectangle is, we have to know the definition of a rectangle, which is just a quadrilateral with four right angles. Quadrilateral is simply four sides, four vertices. We see here we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So all of them have four sides, four vertices, but as we're looking at the markings, we see that only one of them has four right angles. These little marks here indicate right angles. So this would be the only one, figure C, that qualifies as a rectangle. Which figures are squares? Squares are going to be similar. It's a quadrilateral, but all of the sides are the same, and they are also has four right angles. So squares could be considered a type of rectangle where both all four sides are going to be the same length. So we see that this obviously, the only one that could apply would be this rectangle here, but we see that we have 3 centimeters on top, 3 centimeters on top and bottom, but on the sides we have 6 centimeters. So none of these figures are squares. And then which figures are parallelograms? Parallelogram is a type of quadrilateral where we have a couple of parallel lines. So we have, if we're looking at these, we see that obviously this figure here in the middle, we're not dealing with parallel lines at all. Here, if we look at the rectangle, is this a parallelogram? Well, we know that these lines here are the same distance and these are the same distance. If you have the same distance on top and bottom and on the sides, then it's going to be parallelogram because these are never going to touch here. If we create a line that's 3 centimeters long, we could create a different line coming off of this. We could create several different lines coming off of this. We could create a line that looks like this or a line that looks like this. However, if we know that further down on the side that this distance from here to here is the same as 3 centimeters, that these lines are changing at the same rate and that they will never touch, that these are going to be parallel lines. And if so, the right angles are another indicator. Hey, if we're creating right angles, if this is a 90-degree angle here, this is also a 90-degree angle. This is as well as 90-degree and 90-degree. These are going to be exactly vertical. They'll never touch. We also know that these are parallel as well because of these angles here. So we have figure C that's a parallelogram. We would also look here and notice that this here, if we were to create right triangles, could also be a rectangle. Based on the same thing, it doesn't give us the angles, but knowing that this is 6 centimeters, this is 6 centimeters, and the sides are the same, because the sides are the same, it's the same idea here. We could create any kind of angle. If I only knew this side here, and I knew this angle and this side here, so 6 and 4, and I wanted this to be 6 centimeters, I could create something like this at 6 centimeters. I could create something that went down like this. However, if another line connects and is the same distance, 4 centimeters and 4 centimeters, then we know that these lines are parallel. So here we have a parallelogram as well. This is figure A. It also applies as a parallelogram.